So today we really have the same learning goal, and we will here probably through tomorrow. I can use the exponent properties to simplify expressions. So yesterday we talked about those 5 that were really just ones they expected you to already know. And you need to know them. So remember I said yesterday, that's really part of your homework also. To get those properties memorized, know them, know how to use them, okay? And then today we'll introduce the negative exponent property and the 0 exponent property besides. So, one thing that is oftentimes a confusion for students is they think that when you're taking a number to a negative power, that's going to make the answer negative. What did you learn in your SQ3Rs when you were doing your own note-taking in this lesson? Do negative powers make the simplified expression negative? No, that is not what should happen. Can you tell me what should happen? It becomes a fraction. Yeah, it ends up becoming a fraction to get rid of the negative. And did anybody study that thing in, I think there was something in the book that showed you why negative powers become fractions. Anybody have that in their notes? Maybe I'm wrong. Maybe they didn't do that in the book, but I'm pretty sure they did right away on the middle of page 392. Because you know what, it's just not a good idea just to know the property, what you got to do, but why does it become a fraction? So why does it become a fraction? As the exponent powers decrease, so let's say, where did it start at in this table? It started at 5 to the 5th, it went from the 5th, let's start at the beginning of the table, to the 4th, to the 3rd, to the 2nd, to the 1st, to the 0 power, to the negative 1, to the negative 2. What happens as you move down with your exponent? Your exponent gets 1 integer smaller. Caden?
It divides by 5.
It divides by 5. So if you're dividing by 5, then when you get into negative territory, what has to happen? It gets to be a decimal, it gets to be a fraction, it gets to be smaller, doesn't it? Because when you have that 5 to the 5th power and you divide it by 5, does it end up with a smaller number than it was when you get to 5 to the 4th? Yeah. And 5 to the 3rd is smaller yet. And 5 to the 2nd is smaller yet. And 5 to the 1st is smaller yet. And so it has to turn out to be, it didn't end up making it negative. All it does is makes it a smaller number. So we want to make sure we put this in our notes. Taking a non-zero number, so in other words, any number except 0, taking a non-zero number to a negative power does not make the answer negative. Just get that in your brain loud and clear. A negative exponent does not make it negative. We are not multiplying by a negative. That is not what's happening. Okay, well, what happens when you take a non-zero number to the 0 power? It becomes 1. Again, oftentimes students think, well, if you're taking it to the 0 power, it's like multiplying by 0, and when you multiply by 0, what do you get? 0. But that's not what's happening when we're taking a number, a base that is not 0. When we're taking any other base to the 0 power, we do not get 0, so we're going to say it does not make the answer 0. It makes it what? 1. Every time? Let's check it out with our calculators. Use the exponent key, whether it's the upside down B or the x to the y power or an x to the empty box power. Errors by saying to you guys without calculators today. You need to get one. This is not optional. Sell your cell phone and get yourself a calculator. It always equals 1? Did you try to take 0 to the 0 power anyway?
It doesn't.
It doesn't work. Oh, because you can't. It says right there, taking a non-zero number, right? So you should get error when you take 0 to the 0 power. It's the only number you can't take to the 0 power. Would you even try a fraction? And then you need to put it in parentheses. So let's try 1/3. Put parentheses, 1 divided by 3 parentheses, and take that to the 0 power.
Yes.
And what do you get? Isn't that amazing? Take a negative number to the 0 power. Make sure you put the negative number in parentheses because you want to tell the calculator, I'm taking a negative number to the 0 power. So pick any negative number you want, I don't care what it is. What do you get?
1.
Anybody else get 1 or just Deb? You got -1. I have a feeling Kaden did not use parentheses. Oh,
So I use parentheses.
if you use parentheses, you get 1. If you don't use parentheses, you don't get 1. You get -1, don't you? We're going to talk about that in a little bit, why it's so important, those darn parentheses. When do they matter, and when do we get to say, oh dear, there's a reason why they're not here. So, what's the only number we can't take to the 0 power? 0. Any other number will give us 1. Any other base will give us 1. So, again, we have to make sure that our brain does not, trick us into thinking that if we're taking something to the 0 power, we're going to get 0. No, no, no. We're not multiplying by 0. That's not what's happening. So here are the properties we can count on. When x is not 0, remember, it can't be 0. When x is not 0, we can count on the base x taken to the 0 power is always going to give us 1. We can just count on that. We don't even have to check it out in the calculator. We can count on that when we have a base that is not 0, taken to a negative power, how can we, because here's what they say to you. It is not simplified if you have 0 or negative powers in your answer. So how do we get rid of the negative power in our answer?
Make it a fraction.
Make it a fraction. Well, what does that fraction look like then? What would x to the negative n power look like as a fraction then?
Be x under 1 or x.
X over.
No, be x under.
Yeah, x under 1, yeah.
Like that?
Yeah.
Then don't change, we change it to a positive power instead of just being negative.
Yeah. I still gotta have the power, don't I? Yeah, I can't ditch that. So it becomes 1 over x to the positive power, the opposite of the power it was. And then, well, what happens when that negative power is in a denominator? Now what?
Make it into a whole number.
Make it into a whole number. Okay, how? These are magic words?
Why don't you just multiply the denominator times the numerator?
Multiply the denominator times the numerator. It's not going to change it though, because the numerator is 1, and if I multiply the numerator, that 1 times that x to the over x to the negative n, it's still going to be x to the negative n on there. So what's that going to do? Did you not learn that in your SQ3Rs? I did. Come on. What did they teach you in that lesson? This property should be in your SQ3Rs. I don't know why it's not. Good thing I'm backing you up here. How can I rewrite 1 over x to the negative n power?
Just did the same thing.
Just ditch the negative sign and leave it 1 over x to the n power? No, I don't think so. Well, maybe this would help if we did this. Let me, if you think it's complicated, then let me help you understand the complication. What is x? Well, how can we rename just that denominator? We already know how to rename that. How can we rename that denominator? It'd be 1 over, so I'm going to say that this 1 is going to stay 1, and now I'm going to make a fraction within a fraction. You know how I don't allow that, but we can for a moment. We can't leave it like that, though. Well, then that means I have 1 divided by 1 over x to the n power. So let's write it like that. 1 divided by 1 over x to the n power. Well, since we have a fraction involved, it'd be good if the other one was a fraction. So how can I make 1 into a fraction?
1 over 1.
By putting it over 1, okay. Well, as long as you can divide across nicely, both up and down, life is good. 1 divided by 1, is that nice?
Yeah.
Sure is. What is 1 divided by 1?
1.
1. How about 1 divided by x to the n power, is that nice?
No, we don't know x or n.
Exactly. So that's just going to take us back to the fraction 1 over x to the n power, and then we didn't get anywhere. So what do we do when we can't divide with fractions? Multiply by the reciprocal. Okay, so then this is going to become 1 over 1. We don't change the first fraction, even though if we did this one it wouldn't matter, but we don't change the first fraction. We change it to multiply, and we flip, right? We reciprocate. X to the n over 1. I think we're getting somewhere. I get it. What are we going to end up with?
Xn over 1. No.
X to the n power, because 1 times that is just that, right? And 1 times 1 downstairs is 1, and what can I do with that 1 downstairs? Just ditch it, yeah. Well, look at here. Here's what this property says. If you have 1 over x to the negative n power, you have a negative power downstairs, it jumps upstairs and it becomes positive. Isn't that cool? These are the properties we have to add to our properties we had yesterday. So now we're up to 8 of them, aren't we? Okay, we got to remember 8 of them to be able to use. Questions, anyone? Okay, then this is like my own little sideline kind of here. I'm not sure if I would think they might have done this in your book, but these are very important. Negative 2 to the 4th power does not mean the same thing as parentheses negative 2 to the 4th power. In fact, would you try that on your calculator and see what happens? I want you to check out both of them. Put them in just the way they're stated. What's negative 2 to the 4th power? No parentheses involved.
Negative 16.
Negative 16, okay. What is negative 2 in parentheses to the 4th power? 16. So they're not the same thing, are they? No, they don't mean the same thing. So when we don't have the parentheses, we have negative 2 to the 4th power. Only the 2 is being raised to the 4th power. That negative sign out front, remember, what words did I say we could replace the negative sign with besides negative? It's a little phrase that has 3 words. A negative sign also means the
Add the
opposite
opposite.
of. We're not going to change the operation. Negative sign actually means the opposite of. So this is actually saying the opposite of 2 to the 4th power. So the negative sign, we're going to put it out here and say, you know what? It's its own thing. The opposite of 2 times 2 times 2 times 2. Well, 2 times 2 times 2 times 2 is what?
16.
And the opposite of 16 is? Negative 16. Just like your calculator said, right? When we have parentheses, and the negative sign is included in parentheses with that 2, that is saying negative 2 is being taken to the 4th power. So we actually have negative 2 times negative 2 times negative 2 times negative 2. Well, when you're multiplying negatives, what happens? An even number of negatives creates a positive. Because by 2's, a negative times a negative is a positive, a negative times a negative is a positive, a negative times a negative is a positive, and when you keep doing that, so we get positive 16 here. There's a big difference. Okay, now you evaluate that expression I have at the bottom there, please. No calculator. We're not using calculators except to explore. No calculators. Take what we just talked about and put it to use. Anybody brave enough to come up here and show us what you did? Okay, come on up, Katie. Think you got it? Okay, let's see what Kaden gets. Yep, that's a vertically equal sign, huh? Cool, okay. Okay, we're just gonna get rid of some of his jacket, extra stuff going on here, because that's what, clothes do to the board too. Okay, anybody want to agree with Kate that the answer is positive A?
Yes.
Yeah? Okay. Anybody want to disagree? Give us some good reasoning, because maybe all these people are wrong, and you get to be the genius today. Anybody want to convince us otherwise? So, it looks like Caden does not think that this negative sign, whoopsie, that's not what I wanted to do. This negative sign out front here is the part of the power, is it? No. It's standing for what again? No, not adding the opposite. The opposite of. The opposite, you know what, that might be a good thing to put in your notes. The opposite of. That's what that negative sign is saying here. Take the opposite of -2 times itself 3 times. And what is -2 times itself 3 times? -8. Oh, so we're actually taking the opposite of -8. And the opposite of -8 is +8. So it's going to be really important that you understand all of this, like signs and parentheses and what do I do and does that belong to that or doesn't it? And it's just all stuff you got to know. Questions? Okay, let's go to the back then and do some check it out problems, and then you can see how you did on yours. Okay, we're actually doing, looks like check it out problems for example 2. But really important up there what I stated, an expression is not simplified. You will lose points on an assessment if you leave negative or 0 exponents. Is not simplified if. Underline that. That is huge. Circle it. Star it. Bold it. I don't know. Do something to it. Because you do not get to say you're done simplifying if there's a negative exponent and or a 0 exponent involved in the expression. So how would we do 10 to the -4 power without a calculator?
10 times 10 times 10 times.
Take 10 times 10 times 10 times 10.
No. You can,
-10.
you can
Yes,
put it
negative
over
10.
1/10/4.
Oh yeah, remember a negative power does not make it negative, it makes it 1 over that as a positive. And then 1 over, now we're going to take this and simplify it some more. 10 to the 4th power is what, class?
10,000.
10,000, a 1 with 4 zeros. And once it's past 1,000, it has to have commas. Okay. Do 2b then. What is 2b supposed to look like then? And this is the kind of work you got to show me, okay? Don't just go straight to the answer, otherwise I'm going to be like, oh, darn thing, use the calculator. I'm especially going to know you use your calculator if you get a decimal. Don't forget to use parentheses, they're important. See if you agree with me.
Yeah.
Do those parentheses have to be there in that denominator? Yes. Those parentheses are saying the base is what? What's the base? -2. Those parentheses have to be there because the base was -2 when it was taken to a negative power. The base has to remain -2 when it becomes a positive power downstairs. So again, we didn't end up with a negative answer, we ended up with a smaller number, a fraction, right? Okay, so how would we write the next one? Getting rid of the negative exponent only. 1 over,
Parentheses, -2, parentheses, 5.
to the 5th power, that eliminates the negative power for us. When you're multiplying an odd number of negatives, what should your answer end up?
Negative.
Negative. And we just have to multiply one more time times 2, which is 16 times 2 is 32. So this would be 1 over 32, and that would be a negative 32, but
There is no negative exponents.
then we have one, well, there's no exponent there anymore, right?
Right.
The 32 is negative, correct?
Yeah.
Is the upstairs negative also?
No.
No. When there's only one negative involved in a division problem, what's the answer? Negative. So we're going to pull that negative sign out front. That's how we would see it in an answer key. 1 over 32, negative 1/32. Pull it out. If it's in the numerator, that single negative sign, or in the denominator, pull it out and make the fraction negative. Okay, what are we going to do in this next one? Are we taking -2 to the -5 power? Or what's our base this time? What's our base this time? Is -2, is it in parentheses?
No.
Then what's the base? It's not -2, it's just the 2. So this actually becomes, remember, the opposite of, that's what this is, the opposite of 1 over 2 to the +5 power. Well, what's 1 over 2 to the 5th power? 1/32. So we still have our opposite of 1/32. Oh, what's the opposite of a 1/32? Negative 1/32. Some of you might be, wait a minute, you said those parentheses are important, but yet we got the same answer as the one before that had the parentheses.
That's because it wasn't an even number.
Good job, Devin. It's because it wasn't an even power, it was an odd power. So we have to be careful that we don't start thinking, oh, she didn't know what she was talking about. It's okay if I don't use parentheses or I ignore the parentheses.
Too many rules to this.
I know there's so many rules to remember. Golly. Okay, so did you get them right in your SQ3Rs?
Yeah.
Okay, you might want to check that out later. Okay, now we're moving on to the check it out problems for number 3. We're going to do 3A and 3B. Now we're evaluating after substituting a value in for the variable. So we're going to put 4 in for P. How are we going to rename 4 to the -3 power? 1 over what? 4 to the 3rd power, yeah. And then we're going to say, what is 4 times 4?
1 over 64.
Times 4, 1 over 64, 4 to the 3rd power. It would be a good idea to start memorizing some of these powers too. Yeah. You got a lot of memorizing to do. But there's going to be a snowstorm on Thursday, so just,
We don't know. Well, yeah, it's
All we
Yeah.
know
Just
is for
memorize.
sure copycat.
Okay, let's go on to the next one. 8 times, we're going to insert some multiplication dots in here. 8 times a to the -2 power over, a is supposed to be -2. Do we need to put that -2 in parentheses? It says right here, put a in.
Yes.
Yeah, the base is -2, so it has to go in parentheses. And what's going in for B? 6. So it's going to be 6 to the 0 power. Now, we're just going to, rename anything that needs renaming, and then in the end, we'll do all our multiplying. 8, should we do anything with 8?
No.
No. Might want to make it into a fraction by putting it over 1. Let's at least do that. How about -2, that base raised to the -2 power? How could we rewrite that?
1 over 2 to the second.
-2 to the second? In parentheses?
Yeah.
Yeah. And how can we rename 6 to the 0 power? 1. And we'll put it over 1, okay. Well then, well, you know what, it's kind of looking like we're gonna still have to, well, no, we can do this, right? 8 times 1 times 1 is? 8. What's -2 squared?
4.
Positive 4, because a negative times a negative is a positive. So we have 4 times 1 times 1. 4.
2.
And that equals 2. Good job. Woohoo! Oh, you're gonna love the next ones. They're just so much
It
fun.
looks so good.
You did not do this in your SQ3R, but you will be doing it in your homework. Okay? You already know the answer. That's good. You think you do. Good deal. Okay, here's what I'm going to tell you. When you're looking for the missing part, the question mark, you're going to focus in on the one that doesn't have the question mark in it. Focus in on the one that does not have the question mark in it and rename it as a power. So in other words, we're going to take that 25 downstairs, and what power could we rename 25 as, Josh?
25 to the -1.
No.
It'd be 5 to the negative squares, or
5 to
5 to
the
the second.
Yeah, second.
Isn't 5 squared 25?
Yes.
Oh, so then let's just rename 1/25 as 1 over 5 squared. Okay? Well, that still isn't going to work because that 5 with the question mark is not downstairs in a denominator, so now what are we going to have to do?
I don't think it's.
Do you? What is it?
It's a negative 2.
It's a -2. Oh.
Yeah. Because I put it into a fraction.
Well, it's kind of like we're unsimplifying, aren't we?
Yeah.
So could this 5 squared move upstairs and become negative?
Yeah.
Could 1 over 5 squared right now get renamed as 5 to the -2 power?
Yes.
Oh, so we're unsimplifying. We're working backwards, aren't we? 5 to the -2 power would get renamed as 1 over 5 squared. And 1 over 5 squared is the same as 1/25, is it not? Well, guess what? We found our question mark, didn't we?
Yep.
Okay. Which one are we going to zero in on?
1.
The one that
Doesn't have a question.
doesn't have the question mark. Okay. So 2 to the -3 power. What could we do with that? I bet we could rename that as a positive power. Would that be a good start? 'Cause
Yeah.
we got that fraction over on the other side. So I'm thinking, if we rename 2 to the -3 power as 1 over 2 to the 3rd power, 1 over 2 to the 3rd power is the same as 1/8. And we're looking for the numerator.
You got it.
We found it. Okay. Oh, this is a tricky one. There's 2 things that don't have a question mark in it and one that does. Huh. Well, since the one that has the question mark in it has the 2 upstairs and this 2 is upstairs, should we mess with that too? Do you think we should mess with this too? Look at here. In the end, I could make this over 1, couldn't I?
Yeah.
And in the end, it's over here anyway. So do we want to do anything with that?
It's
Let's leave it. Yeah, let's just leave that. So now let's take this 3 to the -2 power and let's rename that. So let's go and do 3 to the -2 power. How can I rename that?
1 over 3 to the second.
1 over 3 to the second. Oh, and that equals 1/9. So it's kind of like we just renamed this as 1/9, didn't we?
Yeah.
So 2 over 1 times 1/9 equals 2 over 9. Oh, there's our question mark. We found it. Good job. Whew.
Oh, it's so
Are you exhausted?
fun. I like it.
I don't
You like this though? Oh, come on, we need the challenge every now and then. We don't want our brains to become rubber, or worse yet, mush. Yeah.
I never want to get to push.
Okay, anybody have questions? Remember, if you want to